Zeno's paradox and infinite geometric series. Now, Zeno decided that if we're going to, find the sum of an infinite geometric series, then we should be able to use this rule, because even though, technically we'd never get there, then as we're getting closer and closer to it. So this is the rule, S of infinity equals A of course being a first term, 1 minus R, because as we said, it's getting closer and closer to that sum. Example 28 says a square has a side length of 40 centimeters. A copy of the square is made so that the area of the copy is 80% of the original. The process is repeated so that each time the area of the new square is 80% of the previous one. If this process is repeated indefinitely, find the total area of all the squares. So in other words, we're finding the sum of infinity because it's going to keep going and going and going. So here's my rule, S of infinity equals my A 1 minus R. Now I know my A is 40 centimeters. That's what I'm starting off with. Now this is the side. So the area, because we're trying to find the area of the square, will be 40 squared, which means it's 1600 centimeters squared. And I know my R, so that's my A. Then my R is 0.8 because it's being reduced by 0.8 all the time. So S of infinity will be 1600 divided by 1 minus 0.8. And if you work that out, we're going to get 8,000 centimeters squared. Example 29, express the recurring decimal. There are 2 dots up the top here, one on each one, as a ratio of 2 integers, in other words, as a fraction. So if we look at 0.32 recurring, that's actually 0.32 plus 0.0032 plus 0.00032 plus and so on and so on. So I know my A is 0.32, and I know my R, that is 0.1. So the sum of infinity will equal 0.32 divided by 1 minus 0.1, which means it's 0.32 divided by 0.99, which means 32 out of 99. So therefore 0.32 recurring equals 32 over 99.